watching me on my channel Physics for Students, and I want to share you with a very important update, a change which I am going to do in my channel Physics for Students with the videos related to general relativity and differential geometry. What is the update? See, till now what I have done is that when I am talking of general theory of relativity, I have made a lot of videos which speaks about the subject itself and about how to learn general theory of relativity. If we talk of differential geometry also, I have made few videos on the technicalities, that is the mathematics of differential geometry, and mostly the videos which you all have liked, I am thankful for that, are basically the book recommendation and sending the books to you. I will be continue doing that, but there is a small change. Well, what I am trying to do in the videos first with general relativity is that I am segregating the videos into three parts. The first part are those old videos or those videos which I am still doing, that is basically on the subject of general relativity as a whole, what I am teaching or what are the videos that I am making on the subject itself. That is a beginner's approach to general relativity, learning general theory of relativity, a complete guide to general relativity, all those things. The subject as itself. I am going to put all these old videos and the new videos which are related to the subject overall into one single playlist. Number one. The second thing what I am going to do is that I am going to make a separate playlist where I will be proceeding with what is called the mathematics of general relativity. Mathematics of general relativity means what? I assume that you know mathematics. I am going directly teaching the mathematics of general relativity, Christoffel symbols, derivation, Levi-Civita symbols, parallel transport, covariant derivative, all of those. So these things I have done till now only 4 videos. Right, so I will be considering and completing more videos, so that would be in a separate playlist which is called the mathematics of general relativity. One, the general videos which everybody can watch. Second, those who are mathematically inclined, that is called the mathematics of general relativity. Third thing is the major change is that I am going to make a third playlist which is called how to learn general relativity. Now if you have watched in the earlier videos of my how to learn, it is a mixture. Everybody learns from the mistake, right? I am also learning. So in one video of how to learn, you will see I have given tensor calculus, I have given Newtonian mechanics, I have given special relativity, I have given differential geometry. Everything is mixed up. But I am not going to do that for in the coming future. What I am going to do is that because general relativity is directly related with geometry rather than the mathematics, so I would start teaching general relativity, that is how to learn general relativity, going directly with the differential geometry part of the general relativity. What does that mean? Say for example, I am dealing with something which is called what is a manifold, right? Because manifold is very common. In general relativity we deal with Riemannian manifold, Riemann curvature tensor. So first, in future you will see that when I am making part 2 of how to learn general relativity, I will pick up how to learn general relativity manifold. That means I will be concentrating and teaching and going deep with the first structure, which is manifold. So what is a manifold? What is not a manifold? How will you understand what is a manifold? What are the mathematics of manifold? So you will see it will serve both the purpose. That means I will go back to the differential geometry part, only that part which is required to learn general relativity. Remember, differential geometry again is a huge ocean. So if I jump, I will drown myself. So I will teach manifold which is related to general relativity, only that part, and a little bit of differential geometry of that part, and then into the general relativity. Then say for example I come with Riemann curvature tensor. What is required? Parallel transport, covariant derivative, all those things are required. So again these are related to differential geometry. So part 2 might be will come up which is called how to learn differential geometry, curvature tensors. That means it won't be a very generic video from now on. It will be specific, where I would be teaching you how to learn general relativity with the essential mathematics that is required, differential geometry, and then that part how it is related to general relativity. Why we use parallel transport for general relativity and so on. So the basic update is that first goes one playlist which is the general videos of general relativity. Second goes with which is called the mathematics of general relativity. Third is which is coming up is called how to learn general relativity. Now in this how to learn general relativity, what I would be doing is that first, as I have already expressed, and I'm thankful for the views and the comments that you have made, that I will be first dealing with geometry, obviously, because geometry is the maximum. Once I complete all about the geometrical structure of space-time, covariant derivative, curvature, etc., that means the geometry part of general relativity is now done. What comes next? That is the physics. What is the physics? That is Newtonian mechanics. What is the Newtonian mechanics part? That is gravity. Then I will see, you will see that it is coming up that how to general relativity gravity part 1 or 1.1. That means I will continue teaching you gravity, everything related to gravity, force, acceleration, which part? That which can be generalized into general relativity, that is the Newtonian part. So you will see that what will happen ultimately, the good part of why I have thought of this lesson is that both the differential geometry part will be taken care and its link with general relativity will also be taught. So one part you are learning differential geometry, which is necessary for general relativity at the first go, and then you will go to general relativity. So both of these things are taken care. Number one. Those who want to learn the code structure of general relativity, say for example, those who wants to learn the code structure of differential geometry, what you need to do? Go to my videos in differential geometry playlist, where only the mathematics of differential geometry, details of differential geometry, the books of differential geometry, those things will be given. So for pure differential geometry, those who wants to learn, my videos will continue teaching and going deep into differential geometry. And those who wants to learn a little bit of differential geometry and link it up with general relativity, that will be basically dealt in near future. So one, as I told you, playlist for general, for the mathematics, and the third, how to learn general relativity. These will go in a very detailed manner, not in a very generic way, teaching you part by part whatever physics, whatever geometry and whatever mathematics is required, so that the link between differential geometry and general relativity is clear. You are also learning differential geometry, you are also learning general relativity, so you can say that you are master of both those things. This is the update which I will be making slowly from time to time in my videos. That is something which I wanted to tell you. Thank you very much for watching this video. Please do subscribe to my channel, hit on the like and give me your comments about this update. Thank you very much.